In this lesson, we're going to do some graphical analysis for our functions. So as we said before, when you're looking at the graph, you want to orientate yourself with a situation. So we see the heading and height of a soccer ball. We also want to see our headings of time and height. So time in S, that's our seconds. Height in M is meters. So this is the function h of t, where t is the time in seconds, and h is the height of the ball in meters. We also said we want to orientate ourselves with the scales being used on our graph. So our inputs, we can see that they're going up by 0.1 second increments. They're just marked every other one, so 0.1 seconds. And then our outputs, the height, we're counting by half a meter, just every other one. So we still have counting by halves. We know the scales. We also talked about, before starting the problem, looking at some of the key features represented on our graphs, intercepts, turning points, maximum minimums, and increasing and decreasing intervals. So we also said you can mark a picture accordingly. We can see, based on our picture, we do have intercepts, both x and y. We have both increasing and decreasing intervals, and we do have a turning point where it's changing from increasing and decreasing. We're going to see how those play out with our analysis. So our first question says, what is the y-intercept, and explain its meaning on the situation? We do have a y-intercept, and our y-intercept is at 0, 0, which is also serving as an x-intercept. And what is the meaning of the situation? Well, it means the soccer ball was on the ground when it was kicked. So at time 0, the height was 0. Our next question, what is the domain, and explain its meaning? Well, we have to remember that the domain is the set of all the inputs for our function. And so our inputs are here, t, right, time in seconds. And we can see our inputs start at 0, and they are continuous all the way to 2. So our domain would be a left bracket, 0, 2 right bracket, or if you were writing it as an inequality, x is greater than or equal to 0, but less than or equal to 2. What is the meaning of the domain? Well, domain is the time, so that means the ball was in the air for 2 seconds. What's the range? And explain its meaning. Again, the range is a set of all the outputs for our function, so h of t. And we can see our range starts here at 0, and we're using all the outputs all the way up into including 5. Again, continuous. So we can have a left bracket, 0, 5 right bracket, or if you're writing it as an inequality, y is greater than or equal to 0, but less than or equal to 5. What does it mean? It means that the soccer ball reached a maximum height of 5 meters above the ground. Find h of 0.2 and explain its meaning. So our input is 0.2 seconds. The output would be the height that goes with it. So if we look at our graph, 0.2 seconds is here. Go up to your function to see what you get out, and we can see it's not a grid point, so we're going to have to do some estimating. So I'd say about 1.9, 1.8 seconds. And so we know that about 0.2 seconds after being kicked, the ball is about 1.9 meters above the ground. Find h of t equals 5 and explain its meaning. So we know that the output is 5 meters. We're looking for the input t as to when that happens. So we go to the output of 5 and see where that falls on our function. The input that goes with it is 1. So what does that mean? Well, it means at 1 second after the ball was kicked, it's 5 meters above the ground. Give the interval where the graph decreases. Well, we know that our function is increasing at time 0 all the way up to this point here where it turns and starts decreasing. So the turning point here at 1 cannot be included, so we're going to use a left parenthesis, and it decreases all the way until the ball hits the ground here at 2, and that's where we're going to use a bracket. So our interval, left parenthesis 1, comma 2, bracket. So again, to recap the key features that we saw on the graph, we had an x and y-intercept at 0, 0. We also had another x-intercept at 2, 0, showing it's a continuous function using all the in-between values for the time and seconds, or time in seconds, and the height in meters for our function. We saw that it was increasing until it reached this point here, and then began to decrease. So again, this point here is the turning point. It represents a local maximum value, and so we've got that point at 1, 5 being very important that we use in our questions as well. So let's take a look at another scenario of magazine sales, and this is the function m of d, where d is the number of days selling and m is the magazine sold. So again, d is the number of days selling, that's our inputs, and m, the number of magazines being sold, so that's our outputs. So we're going to do some analysis based on the graph. And so you want to double check again, how are your inputs being measured? We know it's in days, and we can see that we're counting by half increments for our scale. Our outputs, the number of magazines being sold each day. Again, we're going to look to see what the scale on that is. So each one is 5s. We're going to see how we can answer our questions. First one is, what is the y-intercept, and explain its meaning. We have a y-intercept at 0, 0. And so what's the meaning based on the situation? Well, if you haven't been selling magazines, you can't have any sales. So again, before you start, you sold 0 magazines. What's the domain, and explain its meaning? The domain is the set of all of the inputs, and for this, we have to see what type of function we're working with. We know it's function, but it's not continuous like it was before, where we were using all of the in-between values. We have very specific values here. So this is a discrete function. That means we would have to list out the values individually for our domain and range. So our domain, we're using 0, 1, 2, 3, 4, and 5. So we'll list those out with brackets. And the meanings is that you were selling magazines for 5 days. What is the range, and explain its meaning? So the range is the set of all of the output values. And we have very specific ones. It's discrete, so we have to list them out individually within brackets. So we are using outputs of 0, 15, 20, 25, 45, and 50. What does it mean for you? That means that the number of magazine sales per day were 0, 15, 20, 25, 45, and 50. Find m of 3 and explain its meaning. So m of 3, 3 is the input, so we find where that is on our graph, which is here, and we want to know its corresponding output. That's 45. So what does it mean? It means on day 3 you sold 45 magazines. Find m of d equals 50 and explain what it means. So looking at this problem, 50 represents the number of magazines sold each day. We want to find d, the number of days that it happens. We're going to go to find our output of 50 and see what day that happens for. That's at 4. So we know that d equals 4. Therefore, on day 4, 50 magazines were sold. So again, to recap, we have a discrete function here. The key features that we noticed about our discrete functions that we had both an x and y-intercept. Because it's discrete, we know that the domain and range has to be listed out as individual values within the brackets. You will not have any increasing, decreasing, or constant intervals with a discrete function. Now it's your time to practice some more with your interpreting graphs, your graphical analysis, talking about domains and ranges, key features like x-intercepts, y-intercepts, maximums with turning points or minimums as turning points, and doing the meaning in the context of the problem.